Hi, everybody. Thank you so much for being here today. My name is Ridhwana Khan, and today I'll be talking to you about caching on Dev. So before we do that, let me tell you a little bit about myself. So I am a lead engineer at Dev, which is also known as Forum. At Dev, I feel my passion for building really useful things. I enjoy speaking at conferences. I like writing articles. I think it provides me with opportunities to meet interesting folks like yourselves. And I'm super passionate about building communities, both online and in person. This is a photo from a woman in tech community that I was running in South Africa. There's other communities where there's intersection of design and development. It's a really fun thing to do. And the most important thing you should know about me is I'm a cat mom. This little long-haired fellow, his name is Zeus. I give him lots of love, attention, treats, food. In return, he gets hair over my clothes. He vomits on my couch. That's just the way things go. Have any of you been to South Africa? Yes, a few people. So I'm from South Africa, Cape Town, and I'm going to do a quick 1-minute virtual tour introduction. So this is South Africa, specifically Cape Town, where I live. It's an aerial view. That is one of the most prominent landmarks called Table Mountain. It's called Table Mountain because it looks like a tabletop. This is Cape Point. It is the southern tip of Africa, and on the right is the Atlantic Ocean, and on the left is the Indian Ocean, so at Cape Point they meet. This is just some of the beautiful scenic routes where the mountain meets the sea. And we're really proud of our wildlife. We have the big five. We have these animals printed at the back of our money as well. It's the lion, the leopard, the buffalo, the elephant, and what did I miss? Lion, rhino. Oops. And we also have very diverse people in South Africa, different religions, races, and people are really friendly as well. So now that I've convinced you to visit South Africa, today is also my birthday. I feel, thank you. So, funny story, I misremembered my age today, and I was telling my husband, oh, I'm like this age, I'm not going to say my age out loud to all of you. And then he was like, no, but you're younger than that, and so it was a nice surprise. Yeah, I feel very grateful to be celebrating my birthday here with all of you, and thank you so much for attending this talk, and thank you for the organizers for giving me the opportunity to speak. So how many of you have heard of Dev, or familiar with Dev, or use Dev? Okay, cool, a few people. So for those of you who have not heard about Dev, Dev is an online platform that forms a community of software developers. And these software developers are provided with a platform to share knowledge and provide support to each other. Currently, we have around over 1 million users signed up on the platform. And we believe that the software industry relies on collaboration and network learning, and Dev tries to be the place for that to happen. Another nice thing about Dev is that it's open source. So anyone can go there, they can create bugs, they can create features. What, create bugs? We don't have any bugs. I'm just joking, we do have bugs. Bugs, feature requests, they can just learn and share from the code base. Our code is written in Ruby on Rails on the server side, and we have little sprinkles of JavaScript for interactivity and partial hydration. So at Dev, we often get complimented on the speed of Dev. People say that it's really snappy. If you load the homepage, if you had to go on your phones right now and go to dev.to, you'll see that on the homepage, there's many articles, but you'll see very little of a loading spinner. If you go into an article page, you won't even see a loading spinner. It loads up really snappy. So why is it so quick? The main contributing factor is caching. But I mean, caching is like really intimidating. I've been super scared about caching for a very long time. But recently, I've started dipping my toes and I've started like playing around more with it. And whilst I'm not an expert, I'd like to share some of those learnings within the context of dev. So one of the major reasons that dev is such a perfect use case for caching is because it's a read-heavy site. So tens of thousands of users come to dev and they come and read articles. And these articles, once they're created, they very rarely change, which makes it a good use case for caching. I mean, there are some interactive bits, so like reactions, etc., but those make interesting challenges to work around caching. So there are many types of caching. I will be focusing on response caching and the different types of response caching, as well as some miscellaneous caching. Sorry. So let's start off by talking about response caching. Response caching accounts for the majority of use cases on dev. As the name suggests, it is simply caching a response of a request. As a result, when we do this, it will reduce the request time and it will reduce this, the server load time. Sorry, it will reduce the number of requests into the server. So in a typical Rails application, this is what the flow of data looks like. So we send an HTTP request, and that request contains message about the requested resource. It will contain some headers. It will contain the HTTP method. Rails will then, the web server will receive that request. Once it goes to the server, we need to know what route it matches to. Once it gets into the route, we want to see what controller and action that maps to. When the controller receives the request, it will run the code that was for that particular method. And then that code most likely calls a model, and that model will basically make a database request. The controller will package all of that, and it will generate the view. Rails generates the view. Then we send that view back up through a response message again with some additional headers and metadata, and the browser receives that. Once the browser receives that, it basically renders the view. And in addition, it may ask for some more scripts. So it may ask for some JavaScript or maybe some images, etc. So just based on this flow, I mean, we put a ton of pressure on the web server. There are like thousands of requests going through every minute. So the way we want to ease that load is by identifying the content that is mostly static and then possibly caching it. There are many places in the stack that we can implement caching. And one of the more important decisions as developers that we make is deciding where to implement that caching. So these are some of the types of response caching that we use at Dev. So it's edge caching, fragment caching, browser caching. Edge caching is caching that allows us to avoid hitting the web server. Fragment caching is implemented at the view layer for complex view rendering. Browser caching restricts the request to never leave the browser. So each of these strategies has its own use cases. Sometimes we may want to use a combination of the strategies for the most optimized results. An example is at Dev, on the article page, when we have a single article, we use fragment caching because we have like a complex view, but then we also use edge caching because we don't want to keep hitting the web server, but then we also implement browser caching. So let's go through all of these caching techniques and talk about what each of them entail. So edge caching lives between a user's browser and the web origin server. Thus, we reduce the need to go all the way to the origin server. We use Fastly at Dev for edge caching. So a lot of the section will talk about Fastly, but you can apply what I talk about in Fastly to some other caching intermediaries in some form. So the way that Fastly works is it caches our content on an origin called a point of presence. And that point of presence exists all around the world. There are two parts of edge caching that make it really beneficial for Dev. Firstly, we end up moving the memory storage closer to the user. So you'll see, if you look at these different countries, the point of presence is moved closer to the user, and then it links back to the web server. For example, if I'm a user in South Africa, I mean, I don't want to send a request always to the US, and then it hits the web server, and it comes back to me. If we can cache that data closer to me in Cape Town, that makes the request time a lot quicker. Also, the edge network or the point of presence essentially caches a version of the page. And so each time you hit that cached server, you don't need to continuously recompute any of those pages. It's really fast. So some of the benefits of edge caching: server load and stress on the origin server, improving content delivery and response time, thus reducing waiting time on web pages, and also reducing the network load by reducing the amount of duplicated data. So sorry, there is a typo on that. How does edge caching work? So when a user navigates, we hit the edge cache, and that edge cache can either be cold or it can be warm. If the cache is cold, it means that there is no data in that cache. So what happens is that request will go all the way to the web origin server, and then it will go back to the user. But when it goes back to the user, the edge cache retains that information for subsequent visits. That's the process called warming the cache. The edge cache will also the web origin server will also mark that response as a miss. Now, on the subsequent user request, once we've already warmed up the cache, we then hit a warm cache. And that's a cache that is already where data is stored and ready to be delivered. So instead of the user going all the way to the origin server, they can now get their data from the cache. If the cache is warm, that response will be labeled back with a cache hit. Every subsequent user will hit a warm cache up until the time that we expire the cache, or perhaps we purge the cache, and then the process repeats itself. Okay, so this is a page on Dev. It's one particular article. And when we load up this page, the content, you can't see this live, but the content will load up really quickly. If you had to go on your phones, you would see it would load up really quickly. And that's because the edge cache is already warmed up. However, on the first time you would hit this page, you'd see in the network browser that it would say it's a miss, and it would tell you that there were 0 cache hits. So that's how we check if a page is cached or not on our edge cache. So one of the interesting things about this page is that we edge cache our article, and then we edge cache the comments. The reason that we edge cache the comments is because for SEO purposes. However, this left sidebar where the reactions are is more dynamic content. It's things that change per minute as people react to articles. And so we really don't want to cache this and keep having to update the cache very often. So what we do is we load the page from the edge cache, and then we render the sidebar asynchronously. So when you load up this page, you'll see that we sort of set those public server headers. So let's go through what some of this means. A public cache just indicates that the response can be stored in a shared cache. This is usually for like requests that are not authorized and not restricted behind user accounts. The max age and the smax age indicates the number of seconds that a response remains fresh until after it is generated. So they both do the same thing. But then smax age is 30 days and max age is 3,000 days. 3,000 days is a really long number. But we try and use purging instead. So we set a very long expiry date, and then we use purging to be able to get fresh copies. In this case, max age will not take effect, and smax age will override it because it's a public cache. So when the browser essentially sees these headers, it will know that it needs to do some browser caching. So besides response caching, there's just a couple of few miscellaneous caching techniques that we use at Dev. The first one is called counter caching. Counter caching is a caching technique that keeps track of a cached counter of certain records. So at Dev, we have like very complex like model structures is with like big code bases. So we have many has-many relationships and many many-to-many relationships. So for example, a user has many articles, a user has many comments, a user has many reactions, but then also an article has many comments, an article has many reactions, an article has, what did I miss? Yes, you can see that like the relationships, there's many has-many and many-to-many relationships. So these relationships are ideal candidates to be able to display a count of that relationship without necessarily loading all the records for that relationship. So we use a gem called counterculture at dev, and this basically updates counter cache values when we're updating, creating, or deleting. It supports counter caching through multiple levels. It also supports dynamic column names, making it possible to split up a controller cache into different types of objects. And it keeps a running total of our actual resource. So this means if we have an article page where we want to show the number of comments, instead of having to query that through our database and show that number of comments, a counter cache already keeps a separate record on the database article row to show a running total that it keeps updating in the background based on whether we've added or removed a comment. So all we have to really do is then add this migration in this column, and it takes care of itself. Another important function at dev is the use of tags to be able to find more applicable and relevant content. So in order to do this, we introduced the concepts of tags, where an article can have many tags, and users can follow many tags, and so on and so forth. So instead of adding adding tags as a column on the articles table, we include a gem called access taggable on gem, and it adds the associations for us. So again, to avoid the need to eager load and for performance improvements, the access taggable gem sort of allows supporting caching on your tag list, and so it sort of adds a cache tag list to your model, and again, just like the counter cache, it updates that in the background and keeps that relevant. So similar to like cache tag lists, counter caching, we do some other things like caching user info on an article page. We serialize data on notifications in a more efficient way. And this is like a blurred line between like caching and also just a more optimized way for data storage. Okay, so to conclude, I'd like to talk about like some of the questions that I asked myself when trying to determine whether or not to implement caching on a feature. So the first question I like to ask myself is, how often do we see the data of that feature changing? If the data is changing very often, perhaps it doesn't make sense to add any caching. But if it's relatively static content, just like on dev and articles, perhaps it never changes, then caching seems like a really good way to sort of improve your performance of your app. Then another question, once I've determined whether I'm going to be implementing caching or not, I like to ask myself, at which layer of the stack do I need to implement caching? So if it's like a really complex view where I can see like it's taking very long to render, then I tend to sort of go towards fragment caching. But edge caching, at dev, we edge cache a lot of things so that we don't actually hit the web origin server. So like I mentioned earlier, sometimes maybe you want to use a combination of the two because it makes sense. It also depends on your traffic. Like, is the web server being hit a lot? Like, can you see how many requests are coming through? Is it from all around the world? Because then you really benefit from an edge caching technique. There's no real right or wrong answer with caching. It's sort of, this is weird, it's like sort of like a feeling you get based on like monitoring your requests, perhaps putting it through Datadog and looking at how long requests take, looking at what your web server load is, etc. So what we do at Dev is we try to just encourage our team members and contributors to ship a feature and then sort of monitor the feature, be able to analyze the data that we get, and then make informed decisions on, firstly, whether to cache or not, and secondly, how to implement that caching. And that brings me to the end. Thank you so much. Do we have any questions? Also, please leave me any feedback. I would really appreciate it, and it's highly encouraged. Thank you. Any questions?
Questions?
I hope I can answer them.
Yeah. No, so when you were talking about edge caching, you mentioned that you implemented shielding.
Yes.
And that it's not a default for Fastly. So is there some disadvantages why it's not a default and why you then use it, and those disadvantages are not a problem for you?
So we don't necessarily implement shielding, we enable it. So there's like no code changes related to shielding, it's just a configuration setting on Fastly. So yeah, by default it's not enabled, and you as a team make an informed decision on whether you need that extra layer of caching for your website. It's a little bit more management, etc. And as with like caches, like sometimes things go wonky, right? Like if you're now introducing another cache, you have something else to manage. So as much as it enables us to reduce the load on the server, we're introducing another node, which then means more management, more monitoring to ensure that you actually are, to ensure that Fastly is actually sort of, what's the word, to make sure that Fastly is revalidating those caches and refreshing it. Because yeah, with multiple caches, things do tend to go a little bit wonky. Caching is sometimes just complicated.
Thank you. Well, I wanted to ask the same thing, but maybe, so you explicitly tell Fastly to expire a cache when an article is updated, right?
Yes, yes.
So via APIs, how do you do that?
So there was a piece of code that was not super readable. Where is it? This is fragment caching, that one. This is sort of how we set our cache control headers, and we tell Fastly based on that max age. That is telling Fastly how long should that cache still, how long should we use that cache until it gets stale. So by default, we have it set to 1 day, so it will expire after 1 day. And then Fastly will know to expire it through the header that you send in the request. When we're purging it, we need to explicitly, we have a function, a method in dev that will explicitly say, let's bust the cache now, and the cache has a URL. And so you say bust the cache for this URL, and then it basically does it Fastly. Yeah.
Thank you. Thank you very much.
Do we have time for questions?
That's the thing. So we're a little bit behind.
Kay.
Should we?
You can find
take
me
this
afterwards as well.
Okay.
Okay.
Sorry.
You can
You'll
find me
have
afterwards.
to ask the question during the coffee break.
Okay.
Thank you.